Welcome to video lesson 7. In this video, we will be covering inverse of a matrix. I'll also guide you on how to find the adjoint of the matrix directly without finding its cofactor. So we'll start with how to find the inverse of a square matrix. So inverse is denoted by A to the power minus 1, A inverse. Okay, so I'll give you the steps how to find the inverse. So to find inverse, first we need to find the determinant A, then we need to find the adjoint of A. So for 3 by 3, for 2 by 2, you know how to find the adjoint of A. Now find A inverse using A inverse equal to 1 by determinant of A into adjoint of A. So we have 3 steps in finding the inverse of a matrix. So let's look at the example 1. If A equal to 1 2 3 4, find A inverse. So we'll find its solution. So first we need to find step by step. So find the determinant of A. So determinant 1 2 3 4. So 2 by 2, 1 into 4 is 4 minus 6, which is equal to 2. So not equal to 0. You have to write not equal to 0, and at the side you write inverse exists. That means they exist inverse. If it is equal to 0, inverse do not exist here. Now secondly, we'll find the adjoint of A. You already know how to find adjoint of A for 2 by 2 matrix, that is interchanging these two elements, right? You will interchange these two elements for 1, you're interchanging and changing the sign here. So therefore this is new from here, this is new for you. So A inverse is equal to 1 by determinant into adjoint of A. So 1 by determinant, so minus sign I'm writing in the numerator 1 by 2, then adjoint whatever you have got from here you will write here. Okay, so you can take this minus sign inside or you can leave like this, it's up to your wish. Okay, now example 2, this is for order 3 by 3. Okay, so we are asked to find inverse again. So you already know we have 3 steps, that is finding. First step is to find the determinant of A. You also know how to find the determinant of 3 by 3 matrix. So here first we need to assign the sign. So I'm expanding through row 1. I'm expanding through row 1, so plus minus plus. So 5, then this elements remaining here, minus 3, then the elements remaining, then plus 1 elements remaining. So we have converted to 2 by 2 here. Now you find the value. So we are finding the value here. So minus 3 minus 2, 6 minus 8, right? From here, then 2 plus 4. So you're getting, now minus 6 you multiply 30 plus 6 plus 6. So you're getting minus 18. So it's not equal to 0. So inverse exists. Okay, now we have found out the determinant of this matrix. Now we'll find the adjoint of the matrix. In the previous video I have shown you how to find the adjoint by writing this matrix 4 times. Now first you need to find the cofactor in that video. Now in this video I will show you how to find the adjoint directly without finding the cofactor here. So please listen properly here. So what you do is you write this matrix once here. So you here with this pen I have written here matrix once. So once you write this matrix, what you do is you mark it as column 1 and column 2. Not for this matrix here. So this matrix is being covered here. So for this matrix here I am writing column 1 and column 2. So you copy this column 1, this column here once, and copy this column 2 here. Okay, so what I am doing here, I am writing this matrix once here. So C1 5 2 4, so I am copying it here 5 2 4. Similarly C2 3 minus 1 1, 3 minus 1 1, here I am copying this value here. Okay, so once you write this, you copy C1 and C2 at the right hand side. Okay, so once you are done with this, then you get R1. Okay, as a whole you are getting R1 and R2. So you copy this R1 here 5 3 1 5 3, R1 you are copying down here, okay, below. Then R2 also you copy 2 minus 1 2 minus 1. So this R2 2 minus 1 2 minus 1 I am copying here. Once you do this, now same like this. So before you cancel this upper boundary element and cancel the side boundary element. So you are just cancelling this one and this one. Okay, you need not cancel the other two side elements unlike before. Now you're directly getting the adjoint, you're not getting the cofactor here. So what you do is, now you find this value same like before, but there is a rule where if you are writing the element towards the row, you write here towards column here. You're writing this side. If you are multiplying this side, you write here column wise here. So as of now, say I am taking this element, okay. So when I am taking this element, I am going through row wise here. So if I am going through row wise, when you write the adjoint, you write column wise here. So minus 1, minus 1, minus 3, minus 2, first element here. So you are going that side. When you write the adjoint, you write column wise here. So now 2 into 4, 8, minus how much here? 2 into 3, that is 6. Okay. Next element 2 into 1, 2, minus sign is here, so it becomes plus. 1 into 4 is 4. You are getting this value. Similarly, again you go for this side. 1 into 1, 1 minus 9, 3 into 3. So 3 into 5 is how much? 15 minus 1 into 4, that is 4. Similarly, 4 into 3, how much? 12 minus 5 into 1 is 5. So we are done with this. So last one now. So this value here, 3 into 2, how much? 6 plus 1. See, minus is here, so it becomes plus here. So next 2 minus 10, right? So 5 into 1 minus 5 minus 6 here. So you are done with the adjoint here. So you are going to find, so your adjoint is going to be how much now? So your adjoint is going to be minus 5 minus 8, 7, 2, 11, minus 8, 6, 7 and minus 11. So this is your adjoint. See, we did not find cofactor, we did not do anything. This is the direct method to find adjoint. You may try using the other methods. In the previous video I have written 4 times, so you can try using 4 times and you will get the same answer out here. Therefore, A inverse is equal to 1 by determinant of A into adjoint of A. So you simply have to replace whatever you have got, adjoint and determinant. So minus 1 by 18. So the adjoint value that you have obtained before. Okay. Yes, this is the inverse of A. Okay. Now we have another example. Little bit different from what you have studied before. Here also you are asked to find inverse, but only the equation is given. If the equation is given in this form and if you are asked to find the A inverse, we need to find in this way. So you write the equation first, that is A square minus 5A minus 2I is equal to 0. Okay. So now in this equation, from this equation you have to find A inverse. Now to find A inverse, you either multiply this equation throughout by A inverse or you divide it by A. Multiplying by A inverse is same as dividing by A. So if I divide by A throughout this equation, right? So it's going to be A square divided by A minus 5A divided by A minus 2I divided by A is equal to 0 divided by A. So throughout this equation I am dividing it by A, so the equation does not change here. So this is equal to 1A will get cancelled, A will get cancelled. Okay, so you have to take this value up there, and 0 divided by A is going to be 0 only. Okay, so what is remaining here? A minus 5 is only remaining. So when 5 is only remaining, you have to add I out here. Okay, so there is nothing, so you add identity element here, identity matrix here, minus 2 times I. When you take this up, it's going to become A inverse, which is equal to 0. Now from here you are asked to find A inverse, right? So A minus 5I, this thing will not change, minus, so in one of the video I have already told you that any matrix into identity matrix is the matrix itself. So this is going to become A inverse, okay, which is equal to 0. Now from here you have only A inverse, right? So you can find A inverse from here. So if you take this value that side, it's going to become A minus 5I is equal to 2A inverse, right? You're asked to find A inverse, so which implies that 2A inverse is equal to A minus 5I. I'm just interchanging this one. So A inverse is equal to 1 by 2 A minus 5I. So this is your A inverse, right? So if A is given for you, you have to substitute A here and I here and get the value here. This is an alternative way of finding A inverse without finding adjoint, without finding cofactor, okay?